Professor Kate Helsen is well known to most Campus Planus members. She's a former pupil of David Hiley at Regensburg, where she finished her doctoral thesis. Quite fascinating to me are her recent initiatives, among them the Optical New Recognition Project that has just been mentioned, which uses modern technology as if that was a natural choice for a musicologist. I'm particularly happy about that she's going to report today about her experiences with the work of Andrew Hughes and the question how his extremely valuable materials can be transferred into future.
Thank you, Roman. Is this a good distance for me to be away from the microphone? Okay. As a singer, I'm terrified of microphones. So I feel like I'm not quite alone up here. I kind of feel like Andrew Hughes's presence is somehow here. And of course that is what I'm here to do, is to sort of try to tell you what we're doing with the legacy that he left us. I was working with him after I moved back from Germany to Toronto on his last endeavors having to do with Thomas Beckett. He had a kind of a grand plan for all the offices of Thomas Beckett and how they, in what state they were found and how were they different and what were the variants and all of this. At one point this was going to be a 10-volume publication. It ended up that 3 days before he actually passed away, we got the proofs of the first volume in our hands, and I happened to be in Toronto and went and worked with him on it. He was sharp mentally until the end, but it was very, very tough to watch his body kind of betray his mind. He would have gone on forever. So with that, and now as time passes, I think more about our wasabi eating competitions than I do sometimes about his musicology work, because he was quite a guy. All right. So what I need to do here is talk about his legacy, not in terms of wasabi, but in terms of what he actually left us. And I'm going to spend most of the time on the LMLO, the Late Medieval Liturgical Offices, which are probably familiar to you in one form or another. And I will touch at the end on his chant word dictionary and what's in the works for that, as well as then looking at the Beckett databases, the things that he produced at the end of his life in a way that would also make them more accessible, more available, and more comparable to other things of the same ilk. The LMLO itself, just to give you a brief overview, I guess it is an oxymoron with the LMLO, but I'll try. What it is 2 printed books, 94 and 96 they came out, and in them they're essentially giant manuals for his electronic data that came with them. They also have some lists of manuscript sources where this data is from. They also have abbreviated contents of all of these offices that are then listed electronically in full. But generally, and then there's also quite a few tutorials on how to use this stuff and what you need on your computer to make this work, all in the mid-90s. Whoops. So this is what the LMLO data that I'm working most intensively with looks like, if you look under the hood, which is to say that essentially normal human beings go cross-eyed in about 2 minutes and stop. And I know from experience of having people email me and say, I know that there's a chant melody for a particular saint in the LMLO, and I have no idea how to get at it. Could you please, So I'm not going to try to decode this in real time right now, but just to give you a sense of what's going on. So this is a chunk of a very large text file, which I will actually scroll up and down for you later if you want. This happens to be the start of the office for David of Wales. You can see at the very top, That's what it says. There's next a whole bunch of regularly or standardized expressed abbreviations indicating where he found this. So the source, also his, microfilm box happens to be in there. Then there's the contents of the office. If you're used to looking at stuff in Cantus land, you'll be able to see right away, oh, there's a Vespers in there, there's a Matins, it includes an invitatory antiphon, great, okay, oh, look, we have 5 antiphons in lauds. I'm reading that all along one line, right, that's got, M's equals something, that sort of thing. You also have melodic and modal information encoded very idiosyncratically, even before you get to the actual chants. Then, because he was interested in this, you have the bit, do you see where it says G2 names, sort of in the middle? I know this is all really small. But what he would do is take out the proper names in the text of the saint's office and just show those. So if you were interested in text settings of David, right? There would be a way of querying that even in his data pool from the mid-90s. Of course, you can do it now any number of ways. He was making that a possibility easier for the user. We also have, place names up there, etc. Then you actually start into the office. And this I do want to spend a teeny bit of time on because I'm going to stand up. Is that okay? No one has stood up thus far. Can you still hear me? Okay. Because it's important because he encodes the same data 4 different ways, and these ways become relevant. Oh, do you want me to use that? Hello. So, the first way, they're all indicated by different arrangements of these slashes and ticks. Okay? Sorry. Out like this? Yeah. Okay. All right. So basically, you've got one chant here. This is the first antiphon of Vespers, and this line here /0 or little o /nothing, and then the o starts. That is just the text, but there are capitals indicating where the rhyme is. Okay, so we already have a little bit of markup in the text. The next one down, which is / the other way, has some numeric encoding and the word that it goes with. And these numbers all stand for pitches. I'll get to that in a second. But in between there are periods. Those demarcate syllables. The next line down is just the melody with a comma and then the number of syllables after the chunk of melody that you've had. So now that's a way of looking at the various contours, but keeping the syllabic information without keeping the text itself. The next line down is the line that's interesting to the stuff that I'm doing, which is /tick, begins with the mode and the final of the mode, 1D, and then it is just the pitches going across with all of the repeated pitches taken out. So that's what he called the melodic contour or the simplified melody. Okay? Next chant. And he'll do that again and again and again. And that's how that's done. And it's done to 2,862, I think, 3 chants. I'm not sure, 60-something, in this one file. It just goes on forever, right? I'll sit down. I thought that was interesting. I was reading an article the other day, and lo and behold, Andrew Hughes is not the first one to do this. I mean, obviously not. But this is going on in 1677. There was a book put out for essentially monks who couldn't sing very well, and this was a way of teaching them the chant. And it is exactly what that Hughes encoding was, right? Because you're reading a syllable of text, and then you've got a number that indicates a pitch, and then you go on, and it's marked up exactly the same. By the way, that comes from an article in Acta Musicologica from 2 years ago, maybe. Pissarro wrote it, and that is Sueti and his Nouveau Élément des Chants book from 1677. So more recently, this is how Hughes's encoding works. I've given you modes 1 and 2. This is also in the paper, so you've met it before. But this is also the way the other pairs of modes works, as in the final is always 1. So it doesn't matter if you're in mode 8 or mode 2, 1 equals the final of the mode. So 1 can be D, 1 can be G, 1 can be F. There's also a way of indicating if it's been transposed. That's the set of characters. So along with numbers, he also uses the ASCII characters going down as they used to in the keyboard. So below 1 comes 0, and then minus, and then asterisk, and then percentage sign. To this, he then, in the melodic encoding, just the melodic encoding, he marks it up according to the text that sets it. So, period marks syllable change, as I said before. Semicolons in the melodies mark the ends of rhymed text lines. And then ticks are these indication. It's not quite like reflecting the neumes and the way the notes are grouped together, but it is a way of reflecting the most kind of obvious ligatures that he's reading out of the texts. And so those are preserved as well. That was my Facebook page yesterday, so I added it to my slide. This is the kind of stuff that makes me think that making sure that the LMLO data doesn't kind of fade off into oblivion is a good thing to do. There are lots of people who are actively working for whatever ends. I have no idea why Mark Everest would want LMLO stuff, right? But he's saying, hey, this used to be online, now it's not, what's going on? Ika Delos had a way of representing some of the texts in the LMLO, and that's now taken off the web, probably because her husband was running it for her after she died, and now it's just grayed out, so we don't know what happened. It's probably a server thing. Anyway, so this is the kind of thing, I mean, not that I'm trying to toot my own horn, I'm just saying that, like, this stuff, people are using it in ways that I don't really know, and can't sort of predict, but I feel like it's incumbent on the people who have the stuff to be able to make it usable. So what's the first way I make it usable? Well, to make the chant transcriptions, the melodies, into something that quote-unquote normal people can read, I'm using MEI. What is MEI? Music Encoding Initiative. Well, what's that? The people I hang out with in Montreal, I'm not from Montreal, but I work with the music tech people there sometimes. They call MEI a community. And that actually is what it is, because it's a bunch of people, librarians, then musicologists too, but also kind of data monkeys, technology people that like this stuff. And they have a kind of an open community. They have a board of like a standardization board. They have conferences. They meet every year. So it is kind of first and foremost a community. They're also very firm believers in things like open source in terms of a philosophy and an attitude towards the future and all of those sorts of things that you can talk about. What it means technically for me as a chant scholar is that I have to jump up and down and wave the chant flag to get the MEI community to care about chant notation as opposed to modern notation. What you see up there is taken from their website, and that's a breakdown of how do you express using MEI, which is a form of XML. It looks like encoding. How do you get that encoding to be useful to depict chant and chant notation, right? Can't have eighth notes, can't have time signatures, right? There are ways of doing this. There's all sorts of things called schemas or schematas that go under the hood to alter what you're describing and how you're describing it. and we're working on that right now, actually. This week, I got another email from one of the guys that's involved in the standards, and he was asking me a really technical question about if something is allowed or not in Chant world, and so we were discussing it. To break this down a little bit, it works on categories of things that you're allowed to express. Oh, I need that thing again. So the first thing, if you were going to try to express that over there, I've left out the bit with the treble clef and the time signature. But the first thing you're doing is you're saying, out here, the furthest out on the margin, I've got something in a beam. What is that thing? Okay, note. 2 notes. 2 notes in the beam. Okay, that ID number is not something we need to deal with right now. But then you can describe it. Well, it's got a stem on it. The stem direction is up. And it's got a pitch name, a P name, and that's F. And it's got a duration, and that is 8 for 8th note. And then it's got it's an octave. Which octave is it? It's the 4th octave in their ranking system. So now I've expressed that F as an 8th note, right? How do I change that into Chant world? Well, take away the stems. We don't need any of those. If I know the pitch, fine. But let's open it up to pitch relative to other pitch or pitch direction. High, low, neutral, same as before, lower than after, or whatever, right? So there are ways of messing with the categories to allow you to express Chant. I'm going to turn that off again. It doesn't even look like it's on in the first place. Okay. So this is how MEI works to turn numbers into notes. There was a lovely person working for me over the summer who took the great big Chant file and separated them out into their individual feasts, offices. And that's how a little screenshot sample of them, that's what it looks like on my computer. So I've just taken the first because it's A, and it goes on from there. Of course, we got 115 offices to deal with here. Inside each of those folders, it's been reduced to each chant, how each chant looks. Inside each of those, they've retained just the top 2 lines. So you've got all the text information, including the rhyme, and then underneath that, you've got how each word is set to the melody. Okay? Verovio, which I'm going to do on the fly in a second, is an online application that you can throw MEI files into, and it will render the MEI as that kind of notation. So that's as far as we've gotten right now, with MEI actually showing up looking kind of like Chant, so without its staff lines, without its time measures, all of that sort of thing. I'm going to do that right now. So this is live, so of course it's going to not work for me. But I'm going to... Okay, first of all, I need to pull this thing. Oh, yeah, lovely. Okay, there we go. So I'm going to input from my stick here. Yeah, okay, on the stick. This MEI rendition of that chant. Render. There. So you can see it's not perfect. It doesn't look super great. The capitalizations of some of the letters have been retained. Some of the syllables are shifted over. Their dashes aren't anywhere. So this is really still a work in progress, but we're getting there. And what it means is that now normal people can read the LMLO encodings, basically. So if you want to sing this, you can. Okay? So it's going to get better. And I'm sorry that it's not in the shape that I would love it to be, but there it is. Now, okay, so the other bit of this is what happens when you keep the LMLO as data and use it in kind of the way that the South African contingent there is looking at it. I've got a different sort of technological guru to help me with this. But essentially what we do is here's the whole file. I'm just going to show you what it looks like. This is just all the chants in the LMLO. And you can see that going through that and trying to, look for patterns is just crazy. So what we do is we pull out, you remember that line that was just /tick? So we pulled all those out. That's a slightly smaller list. 2,849. Well, I know there's 60 something, so I don't know what's going on there, but there you go. So there's the list. And that is what we're querying now. So already we're not actually querying each iteration of each chant melody, right? We've got that reductionist, all the repeated notes out, all that sort of thing going on. And then we basically ask, okay, how similar is melody A to melody B and C? That's it. Not quantifying by genre or mode or anything if we don't want. What happens is results have to be interpreted in ways that human beings can understand. And the first way that we thought of was looking at it as a matrix. And anything that you see that is red is very similar, and anything that you see that is green is very dissimilar. And that is by looking for patterns of 2, 3, and 4 note groupings. So what happens is you compare every chant to every other chant. And of course, running down the middle line here, it's all red because that's the chant itself being compared to the same chant. So of course, this is kind of flipped. It's going to look symmetrical across that axis. But the idea is here in mode 2, it's very, the melodies are very similar to each other in a way that in another mode, which I don't have here because I want to go on to a different display, would look a lot more green, a lot more blue, because they're all different from each other in that modal group. Okay. This is the kind of new way that we're looking at. And this is what happens when you apply n-grams. That is this idea of looking for similarity in sequence, if I can put it that way. What you can do is you can render the results as each of these points, each of those little dots, is a melody, and then the line connecting that melody to another melody or not indicates, the length of that line indicates how similar that dot is to the other melody, right, that it connects. And so you'll see that some are in big clusters and others are spread and some are totally individual. This is essentially the box and whiskers thing, except now it looks like a spider. I don't know. So this is mode 4. That's mode 6, which is really cool. And also, this was done on Monday. So I don't actually know anything about it. I mean, I looked in a couple just to see what was going on. But in terms of explaining why this looks like this, like I can't tell you that, oh, well, that pod over there is all the responsories or something like that. That's what the humans are for. And we'll get, so essentially what we've got now is we're looking for these melodic patterns. We've got about 3,000 chants. We look across all of the modes. This is, to my knowledge, the first time that this kind of melodic analysis is going on this kind of scale in just the late medieval repertoire. And so people have been talking about, tendencies of conservative composition or not, and all these, the sort of hallmarks of what makes a late medieval chant. So I'm really interested to see that all of this work kind of comes together and presents a cohesive understanding. We can make our search parameters what we will if we make the data just as it is. And we're using algorithms that come from people that are interested in this because they use the techniques in linguistics and also in biocomputing, where they look at genes and how close two strands of DNA are. I'm going to just show you a little bit of what we have so far, but it's very quick. So one of the ways that you can get, and again, we've done these preliminary results essentially so that we can apply for a grant to do more. That is honestly what's going on here. So if it all seems very tenuous and preliminary, that's why. Oh, lovely. Wait, just do it. Yay. Okay. So this is one way that it has spit out data. This is an enormous file, of course. No human being is going to go through this. But this is the result of, okay, let's see what happens when we query all of these chants for strings of between, I think we said like 15 and infinity or something. So every time a riff comes up, right? And so you can say, well, it comes up between these two chants, or it comes up between these 4 chants or whatever. But here we were just looking at the riff itself. Then I wanted to flip it around. So now the riff itself is here, and here is a list of, do you remember that view that I showed you that just isolated the melodies, just automated? So that I'm calling, they're not numbers, they're not like CAO numbers, they're just the numbers in that file. We have to make sure that they point across directly. But you can see that some of them only come up in a couple different chants, these numbers, and then some of them are in a ton of chants. So these are now concentrating on these melodic segments, not the whole chant as the networks did. And then I said, okay, let's see what happens when we only look at the melodic riffs that come up in chants of modes that are not unified by the same final. So a chant in mode 5 and a chant in mode 8, use that. Right? All right. So this is a cross-genre. That's the other thing I needed to say to make that work. Okay, so what's next? What we are going to do is try to use computational biology for genetic analysis techniques and tools to allow us to look for inexact patterns and also mismatched sequence alignment. So if something comes in between 2 riffs, we can just throw that information out and make sure that it doesn't read wrong, that we miss a similarity. The person I'm working with is at Western University with me. His name is Mark Daly, and his work is all over the place, but most recently he's done work on Alzheimer's and also concussion research, and so he's using these kinds of things to look at neural patterns in the brain. So he comes at it kind of honestly from the computational biology side. But we're also using corpus analysis techniques from linguistics and trying to figure out how we can kind of pull that data. The other thing that we're going to do is throw the melodies, once we have them in a nice way, into the Cantus index, thereby increasing that pool. And all of our analysis tools will be on open source hubs like GitHub and Viz and those kinds of things for people who want to talk the lingo, to be able to do it yourself on other strings of data, right? I promised you the chant word dictionary, and I will give you that extremely quickly. So the chant word dictionary, Andrew Hughes encoded every word in the Dominican liturgy from Humbert's Codex and also the work that was done at La Trobe University, the Scribe project that was based on the complete Dominican liturgy. And he threw it into a version of FileMaker, which no one has anymore, and it's incredibly annoying to try to make work for you. I speak from personal experience. Anyway, so it's sitting there now, and it's in this FileMaker form. So what are we going to do about this? How can we kind of liberate this data? Because the interesting thing about this is you say, okay, how many times is et, and, like, set in the Dominican liturgy? Let's just see. And you can just look for it. It's like a dictionary, and it will show you all of the iterations, right? This is nice for people who want to look at text word painting or whatever, right? They're just settings of things, as long as you're happy with just working in the Dominican liturgy. So the idea there is that we're going to liberate all of this from FileMaker and make it an SQL database and put it online. That way the data is in the cloud, it's not on your computer, but you're able to sort of answer elementary questions about text setting. It's also got a bunch of other information, but that's essentially, we'll retain that too, but that's the essential meat and potatoes of that one. He wasn't done with FileMaker though. That's the Beckett Database. It looks like an airplane cockpit. And it has, believe it or not, encoded in all of that. That would be for one manuscript that has a version of the Thomas Office in it. And in there is all the information about what exact chants are in it, in what order, what to compare to, what else am I seeing there? Particular lacuna in the manuscript, the notation, the type of notation, the use, the dating of the thing, the provenance, all of that information is in this kind of view. And again, it's locked in there essentially. So how do you make that become available? Same way, essentially. I think what's going to happen with this eventually is it'll go into the Cantus pool as well. And hopefully we'll be able to make it useful for people who aren't interested only in Thomas, right? That are looking for all the Cistercian books that they can find, and maybe they've missed one that he happened to have seen, right? And cataloged in this way. So there's a lot of information, I think, available in these things that just have to be kind of put into the SQL world so that they can be accessed in the cloud by anybody who's interested for their own purposes. And that is all I have, and it's 4:15. I'm done. Okay.
Thank you very much. I have one or two questions, but we should start with asking whether the Plano has questions. Not a single question. Completely impossible. Yeah. We started with